let's go through like 873, length of longest Fibonacci subsequences. For this question, to give us a strictly increasing array, and all of these integers are positive, and return the length of the longest Fibonacci sequence in array. So Fibonacci subsequence is that for those kind of index I xi plus um xi plus 1 equals xi plus 2. So um, so we are trying to find the longest subsequences, the length, right? So let's look at the example. Let's look at this one, second example. Um, we'll see 1, 11, 12, right? So we'll see this one plus this one equals this. So it will return 3. And 3, this is also length 3. This is also length 3. So longest is 3. But for this one, have 1, 2, 3, 5, 8. This is 5, right? So um, here there is we need to worry about the corner case, right? So if here the thing is that if this kind of array there is no Fibonacci subsequences, it will return 0. For example, we have 1, 2, and 4, right? We cannot find any subsequences. Then we return 0. It is not return 1 or 2, right? So just this will be the corner case. Here, we'll say the Fibonacci sequences, every those kind of I, J, K, right? So we'll say if xi plus xj equals xk, right? Those kind of index. So we'll find just a one dimension will not determine the longest one, right? Because the length, right? Apparently, it has two-dimensional indexes. One is because every, for example, x plus y equals z, right? And we cannot use the kind of z to, for example, to the next one. Cannot, if we want to have a not, this has length 3. If we want to have length 4, right? The next one should be y plus z, right? A number equals y plus z, for example, that is a, right? And then the next one will be z plus a, right? So that means every number they cannot just depending on one of the previous number in this Fibonacci sequences. It will determine on the previous two, which have the sum to current one, right? So that means if we are considering dynamic programming, we should also have two dimension, right? So one dimension is not enough. So for this question, we know if we have then want to so what we need is that we need to find DP should be a two-dimensional array, right? So for let's say this has length n, right? And it will be n multiplied by n array, right? So what we say that DP ij will represent the longest Fibonacci subsequence. The last element is array I and array j. So this is what we define. So every time, for example, we are able to calculate an DPIG, right? We can, for example, use a global result and up every time we update this, and then we have a global result equals max DPIG and the result. Here, for DPIG, right? What's the initial value for this? We can set the initial value for every DPIG to be 2 first, to be 2, because if we are able to, for example, DPIG able to have xi plus xj equals xk, right? Then the length becomes 3, right? For our DP, we'll have DP length plus 1. But if we set this one initially as 0, right? 0 plus 1, it will just become 1, right? So it will not be correct. So what we do is that in the final result, if we have a result is still equals 2, right? That means we didn't update any of our results. Then it will return 0. Otherwise, well, return. That means we have a result being updated, we return the result, right? So we set our DPIG equals 2 as the initial value, any DPIG, right? So this will be the basic concept. So for this question, it is says that the array is strictly increasing array, right? Have this condition, then it will be very simple, right? That we have DP which is a two-dimensional array. We just need to iterate I equals 2, right? And I smaller than n, right? Then for the index which between 0 to I minus 1, right? We can use the 2 pointers. And for the 2 left and the right, right? So that means that if we have array left plus array right equals array I, right? Then we have a local candidate that will have our DP right I will be max.max DP I right I right I and left right plus 1, right? But it's possible there are several combinations which sums to this, right? So for every item, we need to calculate a result. So that will be a 2 pointers approach. Um, so let's write the 2-point approach first. So it will be int n equals array dot length, right? So what we do is that we have int dp equals new int n multiply n. So what we do is that for array d in dp arrays fill d2, right? So what we do is that for int I equals to 2, I smaller than n, I plus plus int left equals to 0, right equals I minus 1, right? So we'll use a 2 pointer. While array left is plus array right is greater than array I, right? Then we need to move our left pointer. Um, while left smaller than right. If right, um, if array left plus array right is greater, if this is greater, then we need to move the right pointer, right? If this is smaller than array I, then we need to move our left pointer. And I will say else if this one array left plus array right is greater than array I. Then we should have a right pointer, move right pointer. Else, that means we find a candidate, right? So we are going to have dp right I will be max dot max dp right um, I and dp left right plus one, right? And we need to here we can have update because I will have a local candidate, right? So we have result equals max dot max result dp right um I, right? And we have left plus right minus minus. And in the end, what we return is return result result if this is greater than 2, right? Then that will be result. Otherwise, will be 0. Result. Actually, we can just return result because otherwise, if it will update, right? Um, it will always have a result, right? So we just return result should be enough. So this will be the two-pointer approach. But for this question, right, you see that it is strictly increasing. That means every data in array is unique, right? So if they are unique, um, so if this question they change, for example, you say that all of the number in it is unique, and it may have positive or negative values, right? We just need to follow the Fibonacci sequence, right? Then we cannot use two pointer, right? So we can use a map to replace two pointer. So here, if the data are strictly increasing, that means those kind of data for every data, right? We can use a map to store its index, right? So what we do is that for example, if this question changed to be every number is unique, there is no duplicate. So we can for every number I, right? We iterate I from 0 to I minus 1, right? J from I plus 1 to N. Then trying to see if we can find index before I, which have the numbers, for example, numbers K plus numbers I equals numbers J, right? So in this case, um, we don't need to worry about whether this data is increasing or not. For example, if we have something like 1 and 2, 3, 5, but we have something like 6, 7, or 8, something here, right? So let's say this is 8. This is 9, right? Because they are distinct. We can use a map to store its indexes. So that case, we still find that 1, 2, 3, 5 is as long as it's 4, right? So if this question change, they are unique. We can write something like this, right? So we can have create a map to store those kind of indexes. Then we're going to have map put array I to si, right? And what we do is that we are going to have for int I equals to 0, I smaller than n minus 1, I plus plus. Uh, for int j, so let's say int v equals array I, right? For int j equals I plus 1, j smaller than n, j plus plus. Then what we're going to have, for example, int u equals array j, right? So we have int w equals um, u minus v, right? So if map contains key w, right? Let's say and map get w is smaller than I, then we're going to have dp I j equals dp um, we can have mass dot max dp I j and dp k k just say this will be k, right? I plus 1, right? So in the here we're going to have result equals mass dot we can also update here, right? Result plus mass dot max result dp I d, right? If so this is array j. So this um this question changed to be if this array is every number is distinct, right? And also it can have positive or negative number. But the thing that if this um, question change a little further, for example, it say that the number is not distinct. For example, it has one, two, uh, four, three, and for example, there are two here, right? And two here, and five, and something like four here, right? And eight and nine, for example, right? So if there is duplicate, how can we still do it, right? Um, Actually, here you see we put this number. We assume that is distinct. So for every number, we can use the map to store its index. But the things that we are trying to say is that we actually do not care when we iterate a number. Um, when we iterate to a number I and j, right? We don't need to care about for example, this kind of W or this K, right? We don't need to care about the other case. For example, if we have an, an a number 3 here, right? And we are seeing there are two twos here, right? So do we need to care about these two? Actually, we don't, right? So we just need to care about the latest. Um, so this is J, right? So we just need to for example, this is I, right? This is I, and we iterate J, right? J, for example, J have 5. J is here. And we are trying to find the K, right? So there are multiple K candidates. Do we need to care about this K, some kind of early K, right? We don't need to care. We just need to care about those kind of K, which is just the latest to before this I. So if there are two twos, right? So the one which is closer to this kind of 3 will be much better to be our can be our subsequences, right? Because if there is one in the previous um, sequences, one and these two can be concatenate to this kind of 3. This one and these two, of course, go through to these 3, right? So and also, if, for example, if we have one to be here, right? Not here. This one can have even longer length than this candidate. So what we need is that we will just care about the closest K index, right? So even there is duplicate, we can do is that we can still use this map, but the thing is that we are not put the index with this kind of array at here, right? So what we need to change is only put map put array I and I here, right? And here when we check this K, right? This K, well, of course, um, map contains this. This K will, of course, be previous to I. Otherwise, then it will contain this key, right? We don't even need to have this kind of condition even, right? So if we write this, right, we don't need to write the code to put every number to have an index first. We just write this. So for this kind of code, uh, theoretically, it can be have negative number. It can have duplicates. It will all work, and they have the same space and time complexity. Will be n square time complexity. And the space, right? Space use two pointer. We don't have a map, but the thing is that this kind of DP is n square time space complexity. So this map is n, right? So use map, it will be more flexible. We don't need to be this kind of strict increasing condition. And use map, we don't even there is duplicate, it will still work. We can also write Python code for this. So we're going to have n equals length array, and we can have a result equals 0. Result equals to 0, and dp equals 2 multiply n for underscore in range n. Then we're going to have map, right, equals this. So for I in range n minus 1, and we are going to V equals array I, and for J in range, for example, I plus 1 to N, right? So we are going to have U equals array J, and let's have W equals U minus J. So if W in map, then we're going to have um, dp I j equals max dp I j, and dp map w um, I plus 1, right? And here we can have result equals max result and dpi j, right? So if we go to this if conditions, right, it will of course will have some kind of Fibonacci subsequences. And after that, after we for the I iteration, we should put map array I equals I, right? In the end, we just return results. It should be minus V, sorry. So um, because this result will only update when there is subsequences right here. So we don't need to write if this one greater than 2, right? Then result. This is we don't need that.